So can you hear me? Hello.
Yes, sir.
Thank you. Right. So yes, you can. Right. So yeah, we have seen about current, voltages, Ohm's law, Kirchhoff's current law, Kirchhoff's voltage law, and in the last class we have seen about superposition theorem as well. Right. So yeah, before going into the last two theorems, right, the Thevenin's theorem and Norton's theorem, we'll see about bridge circuits. Right, bridge circuits, the Wheaton's bridge, what you have studied in your A level, right? Wheatstone bridge, bridge circuits. Oh, sorry. See that. Right. So I'll draw a simple Wheaton's bridge, right? So this is the structure. Hope all of you are remembering this one from your A levels electricity. Right, then here I have the resistor, right? So this is called as Wheaton's bridge, right? So let this be point A and point B, resistor R1, R2, R3 and R4, right? So I can redraw the circuit, right? So I'll redraw the circuit like this, right? Is there anything wrong? Right, this circuit here, I have my point A and B. Let this be R, right? So this will be my R, R1, R2, R3, R4, right? So these are equivalent circuits, right? So what I have done is simply I made it into I just extended this cable and then made it into two potential dividers. If I apply potential difference between these 2 points, then I could say there are some two potential dividers. One is made up of R1 and R3, and the second potential divider is made up of R2 and R4. Clear? Right. So the current through R, right? The current through R is depends on the voltage at A and voltage at B. Right. So I would say if the voltage across A and B, right? Again, I'm saying it is not the point voltages, right? The voltage across point A and B is VAB, and then if the current is I, right, then I could say that I equals VAB divided by R. Am I right? So how can I calculate VAB? How can I calculate VAB? Sorry. Right, if the voltage across, right, let's take it as X and Y, right? B, X, Y is V, then I could say there are two potential dividers. I can easily calculate VA and VB. VAB will be VB minus VA, then I will be simply divided by that one, right? So if the circuit is balanced, balancing means VA and VB are equal. Right? Balancing means the voltages at point A and point B are equal. Then what will be the current? If this is 1.5 voltage, 1.5 voltage, then what will be the current through the resistor? Will be 0, right? Will be 0 because VAB is 0, right? So there are two potential dividers, right? So VA and VB depends on R1, R3 and R2, R4, right? So if the circuit is balanced, which means the voltage at A and B are equal, so there will not be any net current flow through the this resistor, right? The bridging resistor, right? There are two potential dividers bridged by a single resistor. Clear? Right. Now, let's see for the calculations, right? Sorry. Right? Okay. Now, let's assume Vxy is V, right? I'll just make it as V, not Vxy. It will be easy, right? So the voltage across these 2 points are V, right? So what will be my A? VA and VB, right? I can write it as VA equals, right? If I assume this as ground, then VA will be R3 by R3 plus R1 times V. Am I right? Similarly, VB will be R4 by R2 plus R4 times V. Right? So you can easily calculate this one, and then VAB will be VB minus VAO, VA minus VB, right? So whatever the value is bigger, if B is bigger, current flow direction will be from B to A. Am I right? And if A is bigger, then current flow direction will be from A to B, right? You can easily calculate it. If the circuit is balanced, right? If the circuit is balanced, which means these two are equal, right? These two are equal. So I could say VA and VB, right? So I could say R3 divided by R3 plus R1 equals R4 divided by R2 plus R4. Am I right? So V get cancelled, right? Both sides you can simply remove V and it should not be 0, right? We can be rewrite this one, right? So now I can write it as R3 into R2 plus R4 equals R4 into R3 plus R1. Clear, right? So from this one we can derive that, or in other words I can simply say you, if these two ratios are equal to the ratio of this one, right? So 1:10 means 1:10, then the voltage at this point is equal. Or in other words, if this ratio equal, right, R1 1:10 and R2 1:10, then the circuit will be balanced. But remember, cross you cannot go, right? Either this way or the opposite side, right? R1 over R2, right? So you can simplify this one, right? R3 R2, R3 R4, R3 R4. So you can bring it here, R1 R4, right? So there will be, you can simplify this one and then you will end up with, I'll leave this one for you, right? R3 R2, R3 R4, oh sorry, yes, and then R3 R4 plus R4 R1, right? So you can make it as a simple equation and then you can calculate the ratio, right? And then you can move it to the other way around, right? So if the circuit needs to be balanced, then I could say R3 is to R1 should be equal to R4 is to R2, or R1 is to R2 equals R3 is to R4, right? This is to this one. All right. So anything will be okay. Then this voltage will be equal as they are potential dividers, and then there will not be any current, right? If the circuit is balanced, there will not be any current through the connecting branch, right? But if the circuit is not balanced, you can use this equation to solve the current, to calculate the current through the bridge circuits, right? So this is the way, right? There are a few examples I have uploaded. You can practice it yourself. Okay, right. Now we'll move it into Thevenin's theorem and Norton's theorem, right? Okay, I'll share your slide. Okay, we'll go with Thevenin's theorem, right? Yeah. Can you see the slides? Okay, right? So Thevenin's theorem and Norton's theorem are two theorems which can be used to simplify complex circuit into simple circuits, and then you can easily calculate the current through the resistors in a complex circuits. But remember, when you are applying Thevenin's theorem or Norton's theorem, it should be made up of linear resistors or linear network, right? So a linear two-terminal network containing sources which is connected between two terminals can be replaced by an equivalent voltage source VTH in series with an impedance ZTH, right? Where VTH is the open circuit voltage between the terminals and ZTH is the impedance between the terminals, right? So don't worry about this one. I'll explain how we can do this one, right? So consider this circuit. Consider this circuit, right? Okay, I'll draw this one and I'll simplify it, right? But I can do. Right, so you can see the paper, no? Right, the question is, okay, the first question is, use Norton theorem to calculate the current through 10 ohm resistor, right? Okay, I'll draw the circuit first, right? So I have a 10 voltage battery, and then a 2 ohm resistor, right? And then I have another sorry, this is 2 ohms, this is 10 voltage, this is 8 ohms, and then I have 5 ohms. Finally I have a 10 ohm resistance, right? So the question is calculate the current through 10 ohm resistor, right? So whenever you want to solve a circuit right through a single resistor, just mark the points as A and B, right? Mark the points as A and B. Right, okay. If you want to apply Thevenin's theorem to this circuit, right, you need to simplify this circuit into a circuit something like this, right? So there will be a single battery and then a single resistance across these points A and B. Right, this circuit, right? So where A and B, you have 10 ohm resistor, right? So you have to connect that 10 ohm resistor here, but rest of the whole the circuit, right? The whole circuit except that 10 ohm resistance has to be simplified to a single resistor and a single voltage source, where a single voltage source will be VTH and this will be RTH, right? So let's see first how to calculate VTH and then how to calculate RTH, right? So VTH is nothing but the voltage across A and B once you remove once you remove the resistance which you need to calculate the current through, right? For example, in this case, you have to calculate the current through this 10 ohm resistor. So just remove that one. So you have A and B points here. So the voltage across A and B will be what VTH. right? Okay, I'll redraw the circuit again without this one, right? So this is 2, 8, 5, this is 10, right? And this will be my A and B. Now I need to calculate VAB, right? So VAB, which is equal to the VTH here. Okay, right. Now let's see how we can calculate VAB. Right, how to calculate VAB? Right, look at here. There will not be any current flowing through this 5 ohm resistor, right? This is inactive. This 5 ohm resistor does not going to affect anything across the voltage because yeah, no current. AB is open, right? AB is open circuited, so there is no current. So current will be flowing only in this loop. Am I right? Current will be flowing only to this loop, right? I would say this as a simple potential divider. Am I right? 8 ohm and 2 ohm. Right? I can bring this one. Of course, this is open circuited, so nothing useful here. These two will be here. So 8 ohm and then 2 ohm. Voltage will be across 8 ohm. Am I right? So even if I want to redraw this circuit, I can redraw something like this. See, uh, right, this is 2 ohm, this is 8 ohm, this is 5 ohm, and this will be my B. Am I right? A and B. Clear. This 2 ohm resistance, I just simply extend it. Right? Extend it for simplification. Right. Now, what will be my VAB? These are just a potential divider. So I could say VAB will be 8 ohm divided by 8 plus 2 ohms into 10 ohm. 10 voltage. Am I right? VAB equals 8 by 8 plus 2 into 10 by applying potential divider theorem across these 8 ohm and 2 ohm. Clear? Right. Now, what will be my VAB? What will be my VAB? VAB will be simply 8 plus 2, 10. 10 will get cancelled. So will be 8 voltage. That will be my VTH. Right? Thevenin's voltage is 8 voltage. Now I need to calculate RTH, which is this one. Now, right now we have calculated VTH, which is 8 voltage. Now we need to calculate RTH, right? The resistance RTH is nothing but, right? Look at here, the resistance between points A and B, right? So sorry. Here now. Right, VTH is nothing but the resistance between the points A and B after you short circuit the battery. After you short circuit the battery. Okay. So what will be the resistance across this one? This 2 ohm and 8 ohm will be parallel, and then this 5 ohm is connected in series. Am I right? This 5 ohm is connected in series. Right, so these two parallel 8 becomes 2.8 or into 8 divided by 2 plus 8, which is 16 by 1.6 ohms. Am I right? 1.6 ohm, and then this 5 ohm is connected in series, so that will be 6.6 ohm. So my RTH will be 6.6 ohms, right? So I can mark that one as 6.6 ohm, right? Simply, if I connect RTH here, right, which is 10 ohm, right? I can easily calculate the current through this one. So if this is I, this will be my I, right? So I will be equal to VTH divided by RTH plus R, right? If this is R, then I can simply put RTH plus R. So this will be 8 divided by 16.6, right? 10 plus 6.6 will be 16.6. This will be enough for me. If you have a calculator, just simplify it using your calculator and give the final answer. Clear, right? So this is how applying Thevenin's theorem to simplify a circuit. Right, now I'll give you another question, right? Another practice question. What you have to do is you need to tell me what VTH and what RTH is now, right? Okay, I'll draw the circuit. You guys be ready with the pen and paper and try to solve it, right? Okay, I'll give you the question, right? Okay, just have a battery, then an internal resistance, which is 1 ohm. Sorry. 12 voltage. Okay, another one here, 5 ohm, right? 4 ohm, and then I have another resistance here, which is RL, which is equal to 0.8 ohms. Right, the question is calculate the current through this R, which is 0.8 ohm, right? So this is point A and point B. Right, you guys start working out now. I need VAB, which is equal to VTH, and then RTH. Quickly, I give you 3 minutes, right? You can try it yourself and send me the answer through chat. Have you done it? Oops. Well, you are thinking a lot. See, right? So once you open circuited this one, right? So what you need to do is A, B need to be open circuited. Am I right? Once you open circuited this one, right? See, I have A and B. What will be the voltage across A and B? Right? See here, this is simple loop. What is the current through this one? Right? There is only one loop. What is the current through this loop? 12 divided by 5 plus 4 plus 6, 1. Right, 12 divided by 10, which is 1.2 amperes. Am I right? Then what is the voltage across this 4 ohm resistor? 1.2 into 4, which is, yeah, 4.8 ohm resistor. Right? 4.8 ohm resistor. Right? So can you understand? Right? There is only one loop, right? If the R is open circuited, right? If the R is open circuited, there is no current through this loop, right? No current is blowing across this one. Only the current will be flowing in this loop, right? So in this loop, if I apply Ohm's law, sorry, KVL, 12 equals I into 5 plus 4 plus 1, right? 5 plus 4, 9 plus 1, 10, right? So I equals 12 divided by 10, which is 1.2 amperes. And then what will be VAB? Yeah, simply 4 into 1.2, 4.8 amperes. Am I right? Sorry, 4.8 voltage. Then what is RTH? What is RTH? Yes. What is RTH? If you open circuit A and B, and then you need to short circuit this one, look at here, 4 parallel 5 plus 1, am I right? 4 ohm parallel 6 ohm resistor. Clear? 4 ohm parallel 6 ohm resistor. So 4 parallel 6 means 4 into 6 divided by 4 plus 6, which is 24 divided by 10, 2.4 ohms. Am I right? 2.4 ohms, which is very simple. Now you need to draw the equivalent circuit, which is I have my BTH, and then of course RTH. This will be my A, my RL is 0.8 ohm resistance, right? 0.8 ohm resistance. And I need to calculate the current I. So I equals, right? So VTH divided by this one plus this one. So 2.4 plus 0.8, 2.4 plus 0.8, which is 4.8 divided by 3.2 amperes. Am I right? So 6 divided by 4, right? 6 divided by 4, or 3 divided by 2, which will be 1.5 amperes. Clear? Right? Are you okay? Right. So this is how simplifying Thevenin's theorem. Right? Okay. Right. Now we'll try to solve a bridge circuit using Thevenin's theorem. Okay, we'll try to solve a bridge circuit using Thevenin's theorem. Okay, I'll draw the circuit, right? I'll draw the circuit. So you guys concentrate on how I am doing, and then I will give you a few tutorial questions to solve it, right? Okay, right now. Okay, I have a bridge right here. This is 2 ohm. This is 14 ohms, right? So the bridge is not balanced, right? I'm giving you in a way that the bridge is not balanced, right? 11 ohms. This is 3 ohms, right? So I have a resistance here, which my points A and B. The resistance is let this be 32 ohms. Right, this will be 32 ohms. Then this is connected to a battery which is plus there, minus at the bottom, and the voltage is 54, right? 54. So this is plus minus, right? So this is an unbalanced Wheatstone bridge. Now the question is to calculate the current I. If the balanced circuit, you can simply say that yes, the circuit is balanced. The current through the 32 ohm resistor is 0, right? So this will be RL, right? R equals 32 ohm resistor. You need to calculate the current through this one, right? Now the question to you is calculate the current I using Thevenin's theorem, right? Thevenin's theorem is one of the useful theorem to simplify bridge circuits, right? So, okay, shall we do it? Shall we do the first thing, right? First thing, we need to remove RTH, and then we need to draw the circuit. Okay, I'll redraw the circuit, something like this, right? So, as I have shown you earlier, I'll redraw the circuit in this manner, right? Right, so this is connected to that battery, which is 54 voltages, and then this will be my A, and this will be my B, where this 32 ohm resistor is connected. But when we are applying Thevenin's theorem, that need to be removed, right? So that's why it is removed. Okay, I'll mark it as 2 ohm, 14 ohms, 11 ohms, 3 ohms. Right, 2, 14, 11 and 3. The circuits are not balanced. Right, now what will be my VAB, VTH? Right, VAB equals VTH. Right, VAB, which is equal to VTH. Here I am going to use two potential divider model. Right, two potential divider model. So my VA will be right. So if this voltage at this point, right, voltage at this point, I could say, right, if I assume it as ground, right, if I assume this potential as 0, then VA will be voltage across this 11 ohm resistor, and then VB will be the voltage across this 3 ohm resistor. Am I right? Because I am taking this as a reference. Clear, right? So what will be my VA? If this is 0, all these point voltage is 0, right? The voltage across the 11 ohm resistor, and VB will be the voltage across 3 ohm resistor, right? So voltage across 11 ohm resistor will be 11 divided by 11 plus 2, 13 into 54 voltage. Am I right? Similarly, so I could say 1354. Oh, no, okay, right. And similarly, I can write my VB as, right, 3 divided by 17 into, right, 3 divided by 3 plus 14, 17 into 54 voltages. Am I right? So where the voltage is higher, I could say VA is higher and VAB is lower. Am I right? VA is higher and VB is lower. So the current direction going to be in this direction. And I could say that my VTH is equal to 11 into 54 divided by 13 minus VB, which is 3 into 54 divided by 17. Just simplify, and can you simplify this one and tell me the answer? Right, okay, so I'll leave this one for you, right? So you can simplify the answer and let's take it as VTH. Right, VTH. So you can simplify and then you can get the answer. Now you need to calculate RTH. Here comes the tricky part, right? RTH is actually the resistance across A and B when you are short circuiting the battery. Am I right? When you are short circuiting the battery. Right now, look at here. If I pull off A and B, this is short circuited. Am I right? Oh, I can say that simply this is short circuited. Am I right? If I pull off along A and B, this circuit becomes, right? This is short circuited. So simply I have connected here. If I pull off A and B along the axis, this will become right here the 2 ohm resistor and 11 at the bottom, and then now it is connected in the middle, and then again 14 ohm resistor and 3 ohm resistor. Am I right? So this will be my A and this will be my B. Clear? This will be my A and this will be my B. 2 and 11 are connected in parallel in series with the parallel component of 14 into 3. Right? So now you can easily solve this one. Right? You can easily solve this one. Right? So this will be 2 into 11 divided by 13 plus 14 into 3 divided by 17, right, which will be my RTH. So now I can redraw the equivalent circuit something like this, which will be my VTH, which is this one, right, and then RTH, which is this one. Then they are connected to this 32 ohm resistor, right, 32 ohm resistor. Now simply my I will be, right, if this is I, which is equal to VTH divided by RTH plus 32, where RTH is this one and VTH is this one. Right? You can use your calculators to simplify the answers. Clear? Right. If you have any doubts or any questions, ask me now. Right. So this is the basic for your next theorem as well. Right. Norton's theorem. If you have any problems or if you have any questions in this one, please ask me now. You can put it in the chat box as well, right? If you have any questions, just send me in the chat box. Any questions? No questions. You have understood everything.